Hi there, everybody. First of all, good evening to everyone. Wish you a Merry Christmas and a Happy New Year in advance. Hope you all had amazing snacks in the evening. Just kidding. So today, basically, we'll be discussing about introduction to generative adversarial networks, in short, GANs, and our honorable speaker is Mr. Tarini Tanaya Mohapatra. Tarini, how are you?
Hello, good evening. Greetings, everyone. Hi, I'm fine.
Okay,
How are
okay,
you?
that's great. I guess so. Tarini basically he is from KIIT University. So he's a very big deep learning enthusiast and also one of the most active members in the Nerd Nerd Alpha community. So today we'll be having a lot of fun. We'll be exploring many examples related to GANs. We'll be exploring the architecture, and there is a lot of things in store. So Tarini, how are you doing? What are your Christmas plans?
Basically, as you know, I'm a deep learning enthusiast. So I will be training my models and sipping some coffee, watching my models train. That's all.
That's all. That's all you'll be doing. Okay.
Yeah, learning
Uh,
some new things,
learning.
exploring.
Okay, okay. Pretty much expected from a person who is always keen to learn something new. You do not want to waste your time in Christmas. so, so, what do we have in store today, Tarini? First of all, can you please give a short introduction of yourself so that everyone knows about you basically.
Okay, so basically, as you know, my name is Tarini Tanaya Mohapatra. I am a junior year student at KIIT University. I actually started learning and practicing machine learning since over 1.5 years now, and I've been doing since then. And actually, I love the subject, so I've been passionate about it. Other than that, I love to play cricket. I'm a national level cricketer, and I spend my time exploring about stuff which relates to time and space. So that's all.
Oh my God, that was one hell of an introduction, Tarini. Uh, the national level cricket player hit me though. Like I was not aware of that. so the,
Yeah, I
that was
actually I was continuously for 4 to 6 years, but actually due to Corona this year nothing is happening, and actually I've been out of practice also, so this year is nothing.
okay. That's just great. So Tarini, so basically what are the agenda? What's the agenda today? Like in brief, if you could highlight once again, it would be good, and you can proceed further with your
Yeah,
presentation.
yeah. Uh, so so getting with the agenda, I will actually give a brief introduction of what actually generative adversarial networks are, what's the concept behind them, how do we actually code them. I am actually going to code it in TensorFlow and PyTorch. You can also find online codes for PyTorch, but the concept of applying the code remains the same. I will spend some time giving you some of the key applications, and we will spend some time discussing of what all ideas we have and what can we do with it, what are the few benefits and all, and we will spend some time to discuss about the drawbacks of and drawbacks in the sense why how can they go south.
Okay, okay, that's great. Like I'm really keen to personally know about the applications specifically. With GANs, basically we'll be getting there, of course. So yes, please proceed, Tarini. Please go ahead.
Okay, thank you. So getting started with GANs. So let us first discuss what the name actually means. The name is Generative Adversarial Networks. So let us divide the word bit by bit to understand what it exactly means. Generative. Generative in the word makes us think that there is something that we generate. There's something that we will generate from it. Adversarial. Adversarial means there will be a fight or a conflict. We can also say opposition between two persons or two networks. Adversarial networks. So basically, it means we have a generative network and we have another network which is called discriminative network. They will have a fight or conflict between them. We will get into that gradually. What fight, what conflict, why is that? First, we will discuss the core concept of why GAN. What are we actually doing GAN? So, what is the task at hand? Basically, what we are trying to do is we are trying to generate data points from a given distribution.
Okay.
Let's say we have an example of MNIST dataset. MNIST
Okay.
is MNIST is handwritten images.
Do
Uh,
you
com-
have,
uh,
yeah, do you have like, anything pictorial representation or something that will help, the audience to,
yes, yes. Let me share the screen now.
yeah, please share the screen. It will be good actually to correlate.
So is my screen visible?
Yeah, yeah. I saw anime girls, anime chicks. What's going on, Tarini?
Uh, what to say? Some other things, some things we have to do. Uh, red-handed.
Okay.
So basically, let me explain what MNIST is. Basically, as we can see from the picture, MNIST is handwritten numbers in form of images. These are written by persons or human beings. This is not written by computers, as you can see from the shape and the structure here.
Okay.
We can see that there are different types of zeros. No single zero can be identical or symmetrical to each other.
Okay.
No single zero or one or two or any of the numbers. So these are how humans write. Basically, what can we say? This is the type of example we are gonna take. A single zero is a single image.
Hmm.
So basically, a image will be way too complicated for a beginner to know. Let's start our example with a images are high dimensional, a very high dimensional. Basically, this image will be of 28 cross 28, which will be 756 or 780 something dimensional vector.
Okay.
So basically, let us start with a single dimensional vector.
All right. Yeah, single
Okay.
dimension. Okay.
So what we know is, let's say, as I'm a student, I study in a class. In my class,
You stop sharing screen. Like, are you planning to share something, some content, Tarini?
no. Now only one example. Then I will plan to share the content.
Okay. Please go ahead. Like, you can speak.
Yeah. So basically, as I was saying that I'm a student. So I live in a classroom. Basically, in a classroom, we have 60 to 70 students.
Okay.
What I do is I record each and everyone's weight. I store it in a file.
Okay.
For any of the reasons, I require to generate more of the weights. So let's say I want 100 more weights, but I have only 70 weights. What can I do? I need to generate the sample.
Yes, you need to
I
definitely.
need to generate the sample from the distribution. From the What do I mean from the distribution? let's say if I'm trying to plot the probability density function of the heights of the students, then I will get a graph, a PDF,
Okay.
right? A PDF basically, a PDF is like this. Let me show.
Yeah.
Let me show it.
It would be better if you share some content. Yes.
Yeah.
Probability distribution function. That's what you're looking for, right?
Yeah. So basically, it would look something like this, depending on what type of distribution it is. It may be Gaussian, or it may be normal. It may be a power log distribution. It may be anything. So depending on that, I can actually, every distribution has some parameters. You know, every distribution has some parameters. So if I have those parameters, I can generate any random sample depending on it. You have the library in Python called as random uniform, random Gaussian. You remember?
Yes, definitely. I remember like
Yeah. So basically, how does it give your random data points? It calculates from the parameters, from the standard distribution and the mean in case of a normal distribution. Okay.
mhm.
So for a normal model, like a single dimensional, we have this type of plot, a single plot, which is also called univariate plot.
Okay.
But in case of images, or in case of real life,
Hmm.
the image, the lowest image is 28 cross 28, as we have seen in MNIST. It is basically 28 cross 28, and 28 cross 28 is 20. Basically, a 28 cross 28 is 786 dimensional vector. It is huge. So imagine, how will you visualize a 784 dimensional vector, or how will you find the parameters for it? Is it possible?
Like
It's not.
i- if it's like generally it wouldn't be possible. You'll need something, some special powers to do that.
Yeah. Basically, unfortunately, humans are restricted to three-dimensional objects. So anything beyond that, if you think you can think in 4D space or 5D space, you please need to check a doctor, because that's not possible.
Yeah, definitely.
Yeah.
Once
So
I was trying to, plot how can I visualize four dimension, the fourth dimension, literally on. I was trying to do that. I was so insane, and you cannot believe. So it is not possible. Like,
yeah. So for that, what we are trying to harness, we are actually trying to harness the mathematics and the compute power. So let us come
yeah,
back again to the task at hand. If we want to generate samples like that, let me say this. We
yeah,
this
yeah. Okay, your voice caught off.
is to generate samples.
Could you please
Hello.
repeat, Tarini? Yes, your voice caught off a bit.
Yeah. Oh, okay. I apologize for that. So basically, what is a task at hand? A task at hand is to basically basically sample data points from a given distribution.
Mm-hmm.
So
Okay.
basically, if we know what is the distribution, then we can easily sample that. There is no big thing in it. But for data points like images, we do not know how the distribution is or what type of parameter it requires. So we will train a machine learning model to do that. So coming to the points of GAN. GAN has two type of networks. So let me show you that.
Yeah, yeah. Good. It will be good for reference.
Yeah. So if you see there, GAN has two networks. This one right here, which is shown as X cap, is a generator, and this is a discriminator. These two are neural networks. If you can see that, there are two terms new I showed you, which is discriminator and one is generator. Basically, there are two types of model in machine learning, and you must have known about that, called discriminator and generator. Generator generates things, and discriminator learns the boundary to like discriminate. It's all in the names only. So basically, we want to approximate the original distribution, but how? Let's see that. So let's say we have a data point. We have a this one. We have a data point of one image of a distribution. It is the distribution is D.
All right.
Hello. Yeah. So we want D dash. D hat.
Okay.
What we want is D is similar to D hat. Mathematically, what does similar means? Is similar.
Congruent.
What does it
kind
mean?
of, you can say that.
Yes, we can also say that. Basically, if I plot that if I plot D and D dash D hat, okay, or if let's take a simpler example, as it is machine learning. If I have two data set, D and D hat, it will be able to classify which data point is from D and which data point is from D hat. Let's say one image from D and one from D dash D hat. The task of the machine learning model or the deep learning model, anything you say, is to say, are these two points the same or different?
Okay.
Just like face recognition. I have a sample of image. I have your sample and I have my image sample. If I train a machine learning model to say that, are these two images similar? It will say it is similar or it is not similar. Basically, it will give a probability for that. This is this much similar or this is this much not similar. Okay. Does my point make sense?
Yeah, definitely. Okay,
Yes.
but yeah, please go ahead.
So if my model says that two points are similar, then for most of the points, most or all the points, can I say that the two distributions are the same? Basically, this neural networks or anything which learns from the distributions. So if the two distributions are fully overlapping, so the machine learning model will say it is the same. So in that way, GANs work. Basically, what will it do? This will produce a image, a fake image, or anything generated image from a random noise. This random noise may be anything. We will come to that. It will generate an image. There is a discriminator. It will classify it as fake or real. Okay. So before learning it, why should we learn it actually? So if I said you, coming back to the anime, if I
Hmm.
said you, a simple random noise vector can produce an image like this, would you do that?
Yeah, definitely.
or,
I would die. I would die.
or
Just, just kidding.
or, or if I said these two persons, these two persons are they do you think these two persons exist?
I don't know whether they exist or not. Like, it could be generated by, a GAN.
Yes, that's the same point. You wanna make a game and you wanna have the characters without any legal issues. GAN to your rescue. GAN can produce very realistic looking pictures of faces which never even existed in the world. So see what can GAN help you in.
That
What
is,
what to
that is being criminal. You can create fake
so
passports.
basically
You can easily, criminals can use that as an escapade.
so
They
I
can
just hope that Indian government or the US government doesn't see my video then.
lol. Um,
Basi- Basically everything with with Spider-Man's uncle said, with great powers come great responsibility. So you need to use this tech wisely, or it can if wrong power, wrong persons harness this type of power, then we are screwed. We can say in one form also. And just for fun, let's see how to make Donald J. Trump look a bit like. I think it's like Chaplin.
I
It does
hope,
look fun.
I hope, I hope he doesn't see this.
Yeah. It's not gonna be it's not gonna be taking that well because after the loss. So this is like it. GANs are the most interesting ideas in the computer science today. We can say two models are trained simultaneously by an adversarial way or a conflicting way. A generator, we can think of an artist, think of generator as an artist. It learns to create an image that look real, while a discriminator, the art critic, learns to tell the real images apart from fake. So if
Okay.
you're not an artist but you have currency, let me say you are a bad guy. The bad guy is the generator. The good guy is the cop, which happens rarely. So, what I want to do as a bad guy is I want to produce fake notes. And what discriminator or the police wants to do is they want to catch the real notes. So in that process, it is basically a gamified process, a zero-sum game. In that process, I will learn to do better, and he will learn to do better. And there will come a point after which he won't be able to recognize that this is real or fake because it will be just like real. So basically,
Mm.
you can also print your notes, but I don't recommend that.
Help me print some notes. We can have a lot of money, and I'll spend it on my vacation. I'll travel across the whole world. So will you do
Yeah.
that for me?
If I wanted to do that, then I could have just done that and bought the quantum computer which is at MIT. So basically just a glimpse of what it can do. You can see a GIF here, right? It is a
Yes,
training
yes, I
process of
can.
actually how the images are created from the scratch. See, from a random noise, it comes to a point that you can actually see it that those are like images.
Yes, definitely. So, how are they being animated? How is the stimulation happening?
Okay, we will come to that.
Not
Now let's
stimulation.
come how can we will come to that just right now only. Let's come how to do it in code. We know the concept. Basically, one has to get better at learning, and one has to know how can he or she or the model recognize the fake ones from the real ones. Okay,
Okay.
so we are just importing some stuff like we always do. It's just coding. We will download the dataset. Here we download the dataset, the MNIST dataset. It will load from here. Keras on top of TensorFlow does a great job. Now it is both integrated. We pre-process the images. Basically, here what you will see is we pre-process it a bit differently to -1 and 1. It is one of the tricks and hacks of the GAN to make it work because they are notorious to train. I will come to that point after I am done with training. Normally, what you might have seen is we always normalize it to 0 and 1. But here, we normalize it from -1 to 1.
Okay.
After that, we
-1
create
to
a
1.
data set,
Okay.
a TensorFlow data set to make the process faster, to make the training process faster.
Mm-hmm.
This
Mm-hmm.
is the this is actually the network how it looks. So what it is? X is the original data and Z is the noise. Okay.
Okay.
So from X a data point will go, which is like the Taj Mahal. This you can see the Taj Mahal here.
Yeah.
And from a random noise, it will be a random noise will be passed to a generator. X cap is a generator, which will produce some sort of image. This looks like a Taj Mahal now, but it will not look very soon. It will look after some epochs or after some training. Both will be given to the discriminator. This will check if the images are fake or real. Then after that, by via backpropagation, the errors will be transmitted. How are the errors transmitted? Both will be not transmitted at the same time because our discriminator will be so powerful that we don't want a discriminator too powerful that to classify, even to classify. We want it realistic. So we will pause the training. So we will pause the discriminator and we will apply the optimization to the generator. And when we will apply the optimization to the generator, we will pause the discriminator. All right.
All right. So,
So this is a code to make the generator model. Basically, the random noise, the random noise will be coming to the generator. It will be 7 cross 7 cross 256. This mean the any let us suppose we have taken a random noise of 100 dimensional vector. It will be converted to 7 cross 7 cross 256 dimensional vector. When it will be passed through this dense layer, then dash normalization ReLU. We take leaky ReLU because it has better things. We will
so
after that we will reshape the layer. We will reshape it like a image. We will reshape it such that it will be 7 cross 7 cross 256.
okay.
Here,
So,
here it is different. Here we are multiplying it, and here we are making it like an image.
okay.
The input shape is 100 as you can see here. We can also change the input shape depending on our needs and what are we doing. So
Okay.
after that we will apply some deconvolutions or transpose convolutions. Basically, what is that? Transpose. So given a this is the transpose convolution. The blue image is the suppose that the blue image is the image we produced here. Okay.
Okay.
And this is the image, the white color one appearing to the green. This is the role of transpose convolution. This will make a image like that. It will upsample it basically. Transpose
Okay. So
convolution
this
and
will, okay, this will up sample, you are saying. Okay. Up
yes,
sample or
it will
upscale?
upscaling like like
Ah,
it will go upscaling
okay. Okay. Okay.
from 7 x 7 to 14 to 28.
Okay. Okay. Nice. So
So
finally, like you have added all the layers, necessary layers, and then
yes, and
okay.
yeah, as you can notice this, it is one because it is a black and white image. If it is an RGB image, it will be three, and depending on that, depending
Uh-huh.
on your image, we will assign the channels.
Okay. Okay.
So this is how the model looks.
Uh-huh. So yeah, you're visualizing the layers. Yeah.
Yes. So this is where the reset came, the 7 7 256. This is where we multiplied 1 2 5 4 4. So this is the last layer to 28 28 1. So let's generate a random image.
All
It's
right.
nothing as you can see. We passed a random image, we try to generate it, it's nothing.
Okay.
Now let's make the discriminator model.
Okay.
So we will expect the discriminator model to get the images and the input shape will be 28 plus 28 plus 1. As you can see, the output shape of this will be same to the input shape of this because the images will be supplied to that. See here, you can see the image, right?
Yeah.
So 100 dimensional noise vector will be going to the deconvolution. It will be forming of image like this, and the image like this will be again convoluted. Then it will produce an output of probabilistic output. Okay, you can see the workflow here, right?
Yes. 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 Okay.
Yes.
So
So
can you show
basically,
that once again, like the discriminator in that generator
yeah,
one?
yeah.
Okay.
So basically after a forward pass, we will just from the generated image from the random noise. What we are trying to see is what is the probability, and it's very less. You can see. So this is a loss function. We apply a loss function to every of the models we train because without that we have no way to compare how the model is performing. So I would actually would have loved to go deeper on the loss function, but it is mathematically too rigorous and it will require additional of 4 to 5 hours just to see how how this came to this conclusion or how this conclusion is being applied in the real world. But let's just take it from the paper, the Goodfellow paper, that it is the min max of the discriminator and generator, min of generator, max of discriminator. But to work in real life, it is always different. The papers will say one thing, you have to make it work in the practical world. So you need to do something like that. So this is so for the what what do we infer from the discriminator? Discriminator wants to classify the real images good and the wrong images bad.
Hmm.
So for that only, for the real images loss, it should classify the real output should be like one TF dot once produce a matrix. TF dot once produce ones, and TF dot zeros produce zeros. So basically, for cross entropy, which is generalized form of log loss, it will compute the log loss. For a real image, it should be high. For a real image, it should be high. For a fake image, which it will classify it as a real image, it will be low. So total loss is the addition of both.
Okay.
In as we can see from here, you can see the expectation for x sample from p data means the original data, log of discriminant of x, and expectation of z of sample from z data. Z is the what we want to generate. That distribution is log 1 minus d of g of z, like the fake image.
Okay.
But for the generator loss, we only take this part, the log of 1 minus d of g, because we have no control over d of x. So we will take the df part, and as we want to we actually can't maximize a minimum. We can't actually maximize the loss. So for that, we will minimize it. As all the algorithms which are implemented, like Adam, Nestor accelerated momentum, everything is implemented to minimize the losses. So that's why we have created loss functions like this, so that it can be minimized. It is a modified form.
Okay.
So
So
these are
both
the,
fine.
yeah,
And you're just saving it, like creating checkpoints for
yes, yes, the
callbacks.
checkpoints and some of the model data, like the noise, the dimension of the noise vector, and the number of total epochs to produce, and the number to generate, like the number of images to generate. This is
Okay.
for the easy set of the model. So how do we train this? So basically, what we do is, according to the workflow, we will definitely produce a random noise vector. We will produce the we will produce the generator images from the noise. We will train it, because without training it, there is no point of training. So we will actually pass the image. This is a real image. This the generated image is a fake image produced from the generator. Okay.
Mm-hmm.
So from the generator, from the image, it will come up the real output. The real output will be passed to the discriminator loss, and the fake output will be passed to the discriminator loss. The loss will be calculated here.
So Tarini, someone named Nandini, says hi in the live chat.
Hey, hi Nandini. I hope you're gaining some knowledge from this session.
Okay.
Nandini actually is my classmate and a good friend. She has a lot of interest in AI too. She's
Oh,
also very keen to learn.
okay, that's nice.
Hmm. So I'm hoping that everything is like bit. It's not vague, and it's a bit understood.
Mm-hmm.
So after getting the losses, we will just apply the gradients. This is a backpropagation part. We will calculate the gradients, and we will apply the gradients as you have done in the backpropagation part. So basically, what gradient tape allows us to do is, when we apply the gradient tape on generator, it will not be applied on the discriminator, because we are specifying it to the generator, and vice versa. Because in this way, it is a way of freezing one and apply to the another, because we don't do actually the gradient tape in order for that. Is it like understood, or should I say more about it?
No, that's okay. You can proceed further.
Yeah. So this is just a helper function to like generate and save the images,
Mm-hmm.
and this is
Now,
the main training loop.
mm-hmm. That's fine. Like this doesn't need much explanation. So here,
Yeah,
we'll
just
show
some
the out.
trivial stuff.
Yeah.
This is
Okay.
the output after 100 epochs, I think. You can
Okay.
see that this is like, it is a bit
Oh.
realistic looking.
Okay.
It started from this. It started from this, nothing.
Mm-hmm.
And it like how Drake used to say, I started from the bottom and now I'm here. Just like that.
That's really nice. That's good improvement. Cheers to the model.
Cheers.
on something. Now you will create the GIF below that.
Yeah. For that, we just install these dependencies, and
Okay.
we'll run this block of code.
Okay. Okay.
So this shows a red line because I actually my internet was disconnected and it stopped in this line. That's why.
Ah,
I have actually created that GIF via this code. So it's
okay.
workable. I have tried it.
Okay. 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 No issues. So that was
So let's
a very good walkthrough, and pretty much like one can understand the workflow behind this.
yes.
It was.
So for actually behind knowing the math behind it, it's actually have a beta prerequisites because for that you need to actually understand what probability distribution is, what is conditional independence, what is joint conditional probabilities, what all are those to actually know the math behind it. But you want just the applications, then you don't need that. You just need to know how it works and how do we do stuff.
Yeah. Yeah. So I bet a person like you who would be interested in, making various versions of GAN, like modifying the architecture. And only those people will be interested in,
Yeah,
the math.
actually, that's the point I was going to say. This is not the only type of GAN existing.
Yes.
There are hundreds and hundreds of different types of GANs,
Yes.
one for each task.
Yes. So
So
Tarini,
basically, that,
yes, yes.
yeah,
Continue. Please continue.
yeah. So basically, that's also one of the disadvantages because we don't know how to basically make it one cap fits all head. We can't do that as we are doing it in neural networks or CNN. Any type of image data or pass it into a CNN, it will take care of itself. But that's not the same thing with GANs because for each different task, we have to design a different type of GAN. For
Mm-hmm.
deep fakes, okay, I will come to that. That is also an interesting part. Every application of GAN has a different architecture and a different loss function. So the loss function is calculated from math, but it will be available publicly and you can compute on your own. Kamlan, you were saying something. Please say.
No, no, no. Please continue. No, so
Yeah.
yeah, yeah, yeah. So, like, yeah, you said like you will be also discussing about some of the, industry applications as well.
You can take any of the applications. I will make that session uh, a bit interesting rather
Okay.
than interesting application. I will say all the applications.
Okay.
You can decide whether to make it industrial or fun project. It's your choice.
Okay. Nice. Nice.
So first point, data set generation. As we are creating a data set from the GANs, that's why it will be helpful for like we have actually seen lung X-rays. Like we are going through a very bad year due to the COVID-19, and actually the lung X-rays play a critical part in identifying the disease. So what if we can automate it? It can be very much useful to the parts which don't have the process. Of course we will not only determine based on the output produced by the model, but it will assist the doctors a lot. So for that there was a
Mm-hmm.
basic issue of data set because there was no good data sets available. So with the use of GANs,
Mm-hmm.
a team of researchers from Harvard, they create a data set and they achieved phenomenal accuracies for that. So this is one of the industrial type of application of GAN. So basically, if you don't have a data set and enough data points, then you can generate it with GAN. So what will you like to generate? More of anime?
Yeah, I mean, I would like to do both industrial and like both for fun. In fact, entertainment can also be considered as some sort of industrial use case. Uh, When you're
Yes,
talking about
like this.
anime, I guess it will help a lot, for the animation studios that are into the VFX and the necessary simulations. So it will help them a hell lot if they are able to pull it
Yeah,
off.
yeah, they will save a lot of engineering time and a lot of workload on that.
Also, that will also reduce their investment they, put into in terms of
Yes,
money.
yes, of course, of course. This is how we evolve as a human civilization. This is the scientific. These are all the scientific evaluations of humans. We will try to work less, but have better outputs. Just like this living portraits. You must know who is this picture, but have you ever seen it moving? Ah,
No, like it's fun to
Gans
watch
can make it dance
Mona.
too.
This is so cool, like and Mona Lisa talking, it's there are so many applications like GANs mainly can also use for say there is a painting of Mona Lisa in a museum, and that for the people who will be the tourists, they will have a very good experience if they see a talking Mona Lisa, with some voice also. I guess GANs can be a lot and too much helpful here, I guess.
Yes, yes. Gans will actually be. Think about a place where you don't. That's actually the only picture you have, and you want to interact with it. You can actually do that.
Yes, and in fact, in video games also, in games they have, when they focus on facial animations, GANs can help a lot. I see, if I can say itself, how the eyebrows are moving, the texture of the face, you
Yes,
know,
yes.
they
And maybe you can do something like this. Do you know Smith?
Cardi Smith. I have heard his name. Yes.
No, not Cardi Smith. It's Smith. The American actor. Cardi B is a rapper, American rapper, and the Smith, Will Smith, I think,
Okay. Okay.
the one in the Pursuit of Happiness.
Will Smith. Yes, of course. Like
Yes, yes.
everyone.
Let's see them. Let's see the mixer.
Yeah. 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 Oh my goodness. Oh my goodness. Oh my goodness.
Or
Let's.
make, or maybe make Bernie dance.
Uh, oh lol. Imagine.
I guess Bernie will take it very positively because he is moving his hands
Can you
like he's playing.
can you go back to that pose where they were making that unified Bharatnatyam pose? Yes. 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 Yes.
Yeah, this one.
Imagine. Just imagine Modi instead of that old man there.
तो मित्रों कैसे हैं आप लोग?
मित्रों.
आज
uh,
से डांस बंद.
uh, and I'm really like this is a really very fun session.
Or maybe, do you know you can also make a different type of pizza with the help of GANs?
You mean the texture?
Not texture, giving you a better flavor, a better text. We can also say texture. We can also say flavors. We can also say shapes. Anything.
Using GAN. So you will basically trigger
Cook.
some necessary actions.
Yes,
Uh,
we will actually try to cook using GANs. Not actual cook. The cooks will be different, but we will say the combinations what to do. The GANs will say.
Whoa.
A team from MIT and I think Saudi University or something like that.
My goodness, this is like I'm a foodie man. I am in for this, yeah.
So this is actually a joint project between MIT and GANs. team from these institutions from MIT and Qatar, they are doing it. The researchers looked at the food preparation following the instructions, also changing how food
Damn.
looks after adding a key ingredient, puts food through a process. To achieve this system, they can preserve food as food making through manual. The researchers composed, removing. Matlab, the GAN will take an ingredient and will see how it looks and how it does. So वैसे ही होगा like it will there are three tasks the GAN the classify the toppings by unsupervised learning of GAN, to remove the toppings, to show which what is underneath, and to infer the ordering of the pizza toppings on what
Wow.
depending on what will be better.
Man, Tarini, you did a wrong thing, man. I am going to order a pizza from Zomato tonight. Man, yeah, like this image itself and that idea of GANs, I am drooling now. I'm drooling.
So imagine what I'm actually what this maybe I am a bit pessimist according to my view of point, but what I live on to see is how can we progress as a human or human civilization next 20 years. Think after 20 years what will be the shape of humanity in forms of AI or or in terms of any other quantum computing. Think of the advancements they can achieve.
It would be,
Massive.
yeah, it would be massive. You will see droids talking to each other, like you will see human beings. You can cannot differentiate between a droid and a human being. Like
Think of the positive things. Some people have got no one to talk to. Maybe that thing will be solved when we have virtual real ones,
yeah,
virtual real humans.
yeah. You could, people are facing issues in hospitals. There are medical staff are less.
Yes.
The nursing staff is less. You could replace them with, the vacancy with those type of droids, and they will help out a lot. I mean, it's
if
a good.
if they're more advanced enough, we can instead of putting humans to a difficult task, we can put bots to do it.
Yeah, at the same time, there is this thing of, humanity will complain that you are taking our jobs, you are taking our
No,
jobs.
no. The thing is, when the computer started, everyone said no, computers will do everything, and we have nothing to do. Lol, what we will do? We will
Yes,
have no jobs.
I get your idea that we will evolve with the technology, but
Yes, exactly.
initially there will be some sort of,
Yeah,
uh,
there will be, because
there will
we have got so many the population. We have got a population which is tremendous, and we don't know actual distribution of that. So there will be a different sort of ideas and different sort of knowledge depending on the basic background of what they know of what is AI, because they're considering some as black box, but it is all mathematics and the data we feed in.
yeah, man, like this is fun stuff. Like
Yeah,
really
think of
super.
how much better it will do to humanity. It is like it can be used to synthesize your own molecule.
Yeah, but again, like there is this theory, like if it falls into wrong hands, they will misutilize GANs again. So that's there. I
Yeah,
mean,
so that's nuclear power, nuclear energy.
yeah,
But
yeah, yeah. We reach the generic debate there itself. Like technology can be both created for negative purpose, for both for positive reason as well, motive.
yeah, I don't actually remember, but there was a topic, and it arose due to GANs only. Uh,
Okay.
GANs actually rose when into 2018, but the first paper came in 2016. The idea was way back in 1900s. The idea of a generator and a discriminator and the game theory, there was in way 1900s, but it was made possible with the rise of deep learning algorithms due to the huge compute power and algorithms, and Hinton, godfather of AI, one of the godfather of AI, the backpropagation algorithm made it work. So basically, so when I'm coming to this is like there will be a huge number of things which will be done for a specific task to achieve.
Yeah, definitely. I see the possibilities are really very, like way beyond what human should.
Imagination.
Yeah, yeah, yeah.
Yeah, there was actually a debate on how should research be conducted, because with the rise of GANs in 2016. Oh, I actually didn't say the point now why I was saying the rise of GANs in 2016 to the implementation of useful implementation of GANs in mid 2018 or 2019 gave to the fact that how should research be conducted, because GANs can be used to fool anyone. If you can make Bernie dance so well, you can do anything.
Yeah.
You can actually release a video of President Joe Biden saying stuff which he never said, and he could cause a war. Could but everything is there. Think
that's
of
that's the risk.
yeah,
Should not
like,
fall into wrong hands. So the amount of the risk it poses, it should not definitely come into wrong hands.
yes,
Otherwise,
yes.
uh, you know,
Think of applying the same concept on educational videos. Think you can understand English, I can understand English, but there are some of the people who can't.
yes. In fact, Nvidia actually not. I mean, I'm getting where you are. Like, I got what you are trying to say. So Nvidia released this Maxine called AI based platform. I guess they must be using GANs. So if there is a language barrier, what they do is like they first of all convert the necessary whatever the person is saying, right? They are converting into the necessary language of the host, whoever is trying to understand, right? Say you are talking to Japanese people in
Yes.
English, it will be converted to Japanese text or subtitles. In fact, further it can also be modified to whatever you were saying, right? Like the person is speaking in Japanese, so those things are there. In fact, Microsoft also achieved the same. So this is really like very helpful feature here. It's
Yes.
we are making a very globalization. The concept of globalization is not new, but now globalization will be changed to a whole different level now, because
Think
language
of
barrier is something.
1990s.
Think about Don't think about 1990s. You think about before Christ era, how they were able to like they were able to trade with each other. And now we are in a phase where we can catch fire from the gods. Exactly, we can hack some others. I mean, not hack exactly. We can understand a foreign language easily. You know,
Yes,
live.
yes.
It is being transcribed live.
Yeah, that's
Translated.
a type of engineering hack also.
Yeah. So we have progressed a hell lot.
Yeah, but what I would like to, yeah, we have progressed a hell lot, but we haven't that much, because after all, we are just monkeys.
so, uh,
We are the descendants of the great apes. We are just 2% different from the monkeys. So imagine the individuals, or imagine the species which are 2% greater than us. Think what can they achieve with that? Like the difference between monkeys and us is only 2% of difference in DNA or something. What I was reading in vaguely, but I may not be the true to the most of the facts, true to everything, but I think it's approximately correct. But in that comparison, if a human and the other species has a 2% difference, then they can literally design a spaceship to communicate in light years with using AI.
Man, yes, yes, definitely, definitely. That's,
There
I
are a
mean,
lot of things. We have to be multiplanetary species first of all. AI will assist us. Without AI, it's not possible. If you see the cause and effect.
yeah, definitely. Like for space science, AI has been helping a lot. GANs will definitely, they have been also helping out.
Yes,
So
GANs actually was, I don't actually remember, but it was used for some of the construction work also to
construction.
efficiently design
Okay.
something
Okay.
at a specific, at
Tarini, so you have other things in your notebook, I guess, to showcase.
yeah,
Yeah,
yeah.
please. Yeah.
This is how we can do the edit page picture editing. Like we can how a girl can girl with black hair can transfer into a blonde or have a different hairstyle, have a smile. See,
This
there is
is,
a smile.
yeah, this is Face app.
Yeah. So, or you want your own anime. Everyone wants their own emojis, animes. Who doesn't?
Yeah, definitely. Definitely, like it would be a good, like we already discussed about it. So
Yeah.
this is
Basically, in the tech side,
iOS. Yeah, iOS has this feature, right? You can turn your face into, animated emojis.
yeah, I think they must be using some sort of technologies like this, not so low level, but some of the sophisticated kind, because the machine learning lead of Apple is the person who invented GANs, the good fellow.
Yeah, so yes, yes. Just a second. Actually, it was my cat. He was disturbing me a bit. So
Uh, he was actually focusing his energy how to make this conversation better. You're not getting it.
in fact, like the camera issue wouldn't have happened, right? I would have got him here, and I would have, he would be live giving presentation about GANs with you.
Yes, yes. We could have generated more of his pictures also.
so so yeah.
Saying that भैया मिल गए भाई भाई लोग सब मिल रहे हैं. So what can also be done in industry level? So basically, you can think this as an industry level project of molecules, the animification of pictures as an industry level project. The deep fakes can be industry level projects for edtech university, edtech, like to transfer to like you're making a content in one single language, and you can from in the same content only, with the same voice and the same accent, you can convert that video to different languages to get a large lot of subscribers or different pay users. You can do, I don't know of living portraits, the industry level use, but it is fun. That's what I can say. Data set generation is very crucial to industries, and more of our industry level project is post estimation. Amazon, I think Amazon was working on it. Do you know that the dresses you buy,
Mhm.
model is posing in some pose. So if we don't have access to that model anymore, but we want the picture in a different pose or or full body pose, then we can do achieve it from the GANs.
Okay.
Pose.
This was pose estimation is really like your domain of research work.
Yeah, yeah.
That's been a mystery, huge mystery, and a lot of research work has been going on here. Like I see a lot.
Just like this. If this is a image, this is the condition image. This is generated ones. See the poses. How does they differ?
Mm-hmm. Nice, nice. Okay,
This 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 this.
okay. Now I can see how much you are into her right now. I mean, I can
Uh,
see the obsession.
you got me there. So what if you want to get a picture?
And
Send me a great paintist or a very good painter.
good, the Michelangelo.
So basically, you want a painting from him, but a new painting. So you can do the domain transfer and have a new painting which will be just like his, but a new one.
Is this some sort of transfer learning?
This is some sort of transfer learning, but this is also active area of research. What we will do is we will try to transfer the knowledge of the domain.
Acha, okay.
Domain transfer. Okay, let me show an image of that.
Yeah, better show it. Like it's good to always visualize. Yeah, you start presenting your screen, Tarini.
Now,
No, it's fine now. I guess some bug at my issue. I mean, and
yeah. I guess. So one of the simplest example is this: zebras into horses and horses into zebras. This one, the painting one, I said.
okay. Okay, so this is more of like, style, content and style matrix, if I'm
Yes.
not wrong. Like
Hmm.
when you,
But but we can use it to do domain transfer to this is as I said, this is an active area of research. As
acha,
how this is transferring, we
acha.
can use the concept and research more about it and find out how can we actually transfer domain knowledge.
This is
Image
interesting.
super resolution. This is the famous
Super
project by
resolution.
NVIDIA.
Yeah, so super resolution, yes. In NVIDIA Maxine, it's there. So they are basically like,
Yes.
if there is a lower resolution image, they try to upscale it to a better quality. And that's a very good, like, how they manage the bandwidth and everything. Accordingly, it's a good feature. Like, yeah, I have seen that. I'm very well
So
aware of it.
imagine you live in a crappy place like me, which has got less internet speed,
Yeah,
and the video communication is next to it. What will you do?
yeah. Yeah,
The
definitely.
image
So
super
NVIDIA
resolution.
is, yeah, NVIDIA is at the forefront here. At this,
Yes, yes.
yeah,
That's a good thing about GANs. Now people now think of how much amount of carbon footprints we can reduce just by upscaling from a thing.
yeah. So yeah, I lost you there. Actually,
Oh,
Saurabh internally messaged me that I say we mix Amlan's face with Mona Lisa.
that that will be a great project.
uh, good. That's good one. That's good one, Nova.
Well,
Like.
yes, we can also do that. He will. You have to put it as DP.
Yeah, so yes, you're saying.
So imagine the amount of bandwidth and the amount of carbon footprints we can save by there are thousands and thousands of hours of video communications going on, and for that internet is being produced, and internet isn't magic. Something it is being produced by with the help of electricity,
Hmm.
and for electricity we are using many of the things which are not eco-friendly. So imagine how much we can save there. And image unblurring, we can also use this. It's
Okay, so
I
we
don't
have
know
a
where.
message from Refakat. He's saying that name the painting the nightmare. Yeah, so here is my message to him on a personal note. Definitely, like we'll use your face there and we'll make it a nightmare using GAN. Thank you, Refakat.
Like
Yes.
it's so much cool project. Imagine uh people like I can say that when I was in first or second year, no one was like doing anything. Like there were always like there was also issue of connecting with people.
Yes.
Now people interacting with this kind of projects,
Yes.
they can also get to know each other well. They can at the same time they can
This is
get the
very,
knowledge.
yeah, this is very complicated work though. I mean, it requires a lot of expertise.
Yeah,
It's
but
not
you
that,
will learn a lot. The
yes,
more
yes, definitely. You'll,
the more the learning curve, the more the learning.
yes, yes, definitely. So that's there. So
So where do you use image unblurring? I don't know, but I may have some good advantage to image unblurring.
let's not get there. Let's not get there. Uh, that's okay.
So,
Like I can understand the way you have highlighted it. I can understand how much you want to unblur the image, the specific image that you want to.
that's one of the advantages computer science guys have.
Bunch of nerds in a computer science lab. They are just bored. They will do that. Oh God. Yeah, that was fun.
So imagine the possibilities which can be achieved through GANs. Imagine what can we also do it. There might be a lot of drawbacks, like it is very hard to train it. It is as it is a min max, like this one.
Yes. Min max scaling you were saying?
No, min max a loss function. This
Acha, min max loss.
we can during training. This isn't sure it will be which will be minimized or which will be maximized. In which loop?
Whether
We
the generator or the discriminator. It is
no, no,
very.
no. Whether the generator will be inside or whether the discriminator will be inside the loop. We can
Uh-huh.
actually never say that during training.
So there is a trade-off here.
Yeah. So
Uh-huh.
in one hand we can produce a super best image. In other hand, we will never produce an image.
Nice, nice, nice. So
It
yeah,
is a bit hard to make it work.
yes.
It is computationally expensive. It
Mm-hmm.
requires a lot of GPUs, not a lot of GPUs, but a lot of GPU compute power. Thanks
Yes.
to
For that we
Google.
have NVIDIA.
Yeah. And for poor guys like me, we have Collab.
That's okay. I am also poor. I am also using
Maybe
Colab.
Jeff is laughing behind the
Yeah, Nova, you said
Jeff is,
something.
Jeff is laughing.
Yeah, so Nova is basically muted himself. He doesn't want his audio to be revealed to the public. So he's saying that says the guy who is going to buy a, yeah, sorry. Okay, okay, fine. Okay, okay, fine. That's
Oh, according to that, we can also change your voice with the help of GANs. Oh,
uh, Nova is at an advantage here. He is like in a free will to speak anything he wants, and it won't be, the public won't get to hear it. Only we'll get to hear it. What if like he says some slangs to us? That's not going to happen, of course.
yeah.
Yeah, of course, of course. So yes, Tarini, continue.
So voiceovers. So when so everything has an application. We can use it in film industries also to recreate 3D objects or to recreate some scenes which are not possible by humans, or animes animes to produce new stories, to produce new musics.
Yes, yes, yes.
It
Yeah,
like
definitely.
it can be helpful in that sense too.
So yes, I guess like that was pretty much very enlightening. So any other examples you wanted to discuss about?
So I think I want to know what are your ideas, like what do you want, like what do you think you can do with the help of GANs? Share some ideas.
Yes. So we already discussed it though. I just want to say this again. Like I was in this webinar when one participant actually asked me this query that can we boost know space communication, basically, communication in space, communication between
Yes, yes,
uh,
yes.
the station at Earth and space station using deep learning though. So that was a different use case. So yes, GANs can be definitely used here, I believe. I want to explore that area actually personally. And another one which I am very much interested in, using GANs for CGI animations or necessary non-playable characters, their
Using
facial
GANs for
expression
CGI animations is a
simulation.
reality.
Basically, it will like I'm interested to work on a project on that because I'm a gamer myself and it will be fun for me.
Yeah, like you
You can
will
write, yeah,
like
you can write using GANs for video games if you want to type video game GFX or say anything. Or yeah,
and
or what about
or
Omniverse and GAN? Yes,
space.
definitely. Like in Omniverse, Nvidia have has many variations of GANs, and definitely they are using it. Uh, they're using it already, actually. But I guess the video game companies, I guess all the studios, they are yet to implement it on a massive scale. Although CD Projekt kind of did it for Witcher 3, but I don't know. I'm not sure whether they used GAN.
Yeah,
Basically, yeah,
basically we will know that then we might come up with a new better plan and we
because
will offer.
yeah, I'm telling you the problem statement here basically. So when for the main characters of a video game, right, you have protagonists and all, right. So you use them for CGI animation. You get real people, and they take part in the all the overall animation effects, the sound effects, or the voiceovers, and the facial expressions and everything. But when we are talking about non-playable characters, right, it could be not an important person, just a pedestrian on walking on a road in a game, right? He is not important to us. You cannot get hundreds of people and generate the necessary CGI for that, right? Am I correct here, Tarini?
So
Yeah.
basically it depends on your domain of knowledge.
Yes. So basically, GANs can, I guess, I strongly believe they will help a lot here, a hell lot.
Yeah, if you can make it work, then why not?
So Saurav here says that for Cyberpunk 2077, they used a tool that can easily give facial expressions according to audio. He's checking the tool
That's
name.
also a type of project.
Yeah, so they are using a tool. That means the tool must be using GANs or definitely deep learning. So of course they must be using. It's
Yeah.
a yeah, it's a deep learning use case. So yeah, see where the things have uh, like the label things have transformed into. So yeah.
The world is gonna be competitive.
Yes, yes. Jali, it's called Jali, Jali. Okay, that's the tool name. Maybe whoever is into video games, maybe they can explore this. Like I'll explore this myself. Thank you, Saurabh. So, uh, my my cat is trying to play with the fiber wire of mine.
You are actually not getting him again. He's
I'll try
actually trying to
to
recharge
I will
his.
try to get him a webcam. I'll try to get
It
him a webcam.
will be really interesting to interact with him.
Just a second. Tarini, you carry on with the conversation. I'll just try to get him.
So, uh, the projects, I think, is my voice echoing?
No, no, no. Your voice is not echoing.
Okay. So, basically the types of projects we can discuss the types of projects like if you want to get into the AI job or what anything like that, so what projects can we do? We can do a project like super resolution, which is used many places. We can use a project like emojification, because as you have seen that in iOS it is there, in Snapchat and the Instagram filters. You can see there are a lot of filters. So there is a lot of, I think there may be a lot
Yes,
of GANs involved. Basically,
yes.
basically this will be a very good project for internet-based companies. And for medical applications, as you can synthesize your own molecules, we can come up for COVID drug synthesis. GANs were, I think, GANs were a bit used also. I am not fully sure about that, but I think GANs were also used, and some of the machine learning algorithms to get the drug components. And
Okay.
for fun, you have seen this. And I think we should explore a bit more on food and nutrients, because as humans we can't experiment that much on nutrients. We can, but I don't think, I haven't heard that much. So this is an open place, and basically everything is an open place. It's the starting of an era.
Okay. Okay. So yes.
So
Though,
I was
though.
thinking that how to design better spaceships to do light years traveling with the help of GANs. How to design better spaceships.
that is that is again coming into industrial design. That is very challenging. I don't know how you will use GANs for, or they will solve some part of the problem, which is like that is like a smaller part of a bigger problem, but there are many factors in play here.
Yes, yes.
Light years light years is very difficult. Even there is a video game called franchise called Mass Effect. So basically, like they actually what they do is they have mass relays. Okay, that's my cat. I'll try to get him on camera. So I guess like I have to turn on my. Are you able to see him?
Uh, no, he's
Okay. Okay, I guess okay, got it. What's the issue? I guess it's taking my phone webcam actually. Uh, Never mind. I'll try again.
okay.
Never mind. So
Let him decide your next problem. I think he's trying to get energy from electrical energy from your wires.
uh, yeah, he's a very interesting, intelligent cat actually.
Does he help you in debugging your code?
He helps, then he gets fed up and he sleeps. Unfortunately, I'm not able to start the webcam. So
I
that's
can see your webcam now.
how are you able to see? Like that's freeze frozen image actually.
Oh,
But you can hear his voice, I guess.
yeah, yeah, I can hear.
I hope I could get him on camera, man. I mean, some due to some stupid bug, I am not able to start the camera.
Yeah, there is a lot of bugs. Just wait a second.
When I'm starting, it's showing a frozen image from I was using IV cam, right? Yes. Hello. Hello. Are you there?
Yes, actually, I don't know. I think I unmuted myself anyhow. I don't know.
That's okay. Okay. Some other time maybe we'll get my cat on the session, so not an issue.
Yeah.
I
What's his
guess
name?
his name is Daichi actually.
Yeah, did he come from Japan?
He's you can say indirectly he came from Japan. His soul came from Japan. See, he said yes.
We heard him.
So yes, he also he is interested to work on GANs. He's saying yes. he
He will he will try to he will try to make his own empire, design his own empire, industrial empire with the help of GAN. The rise of
Daichi,
GAN.
the future
The rise
mascot
of
of
Daichi.
NUA. Yeah, yeah. He when you said that he is like yeah he will be he's like yeah he will be the the emperor of the world.
It's like you mortal humans, you don't know me.
Anyways, like jokes apart, Tarini, it was a great conversation. I guess I just wanted to ask, do you have anything else to present?
No, as of now, I don't have anything else to present except if you are willing to learn all the maths, which will take 4 to 5
No, no,
hours
no,
of.
that's okay. That's okay. Like I'm not interested now. Not Daichi is also interested. he also he also said no. So yes, so basically like it was a very good session, Tarini, like especially on the application point of view, both from industrial perspective and also from entertainment, for fun. Like yeah, this was really something new to explore. Actually, some of the things I personally didn't know. For example, I didn't see animated version of Mona Lisa actually. Yeah. Although I saw some similar posts on LinkedIn, but seeing Mona Lisa talking was spectacular actually. It was breathtaking. uh,
You can also make Einstein dance too.
yeah, 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 that's cool, like that application of GANs and
I
the
actually
both.
wanted to see Richard Feynman dance.
Sorry.
I actually wanted to see Richard Feynman dance.
Sorry, I lost you there, Tarini. You were saying?
Mr. Feynman.
Oh, lol, yeah, that would be fun. That would be fun, actually. Yeah, so you gave insights about also, like, we also discussed about how GANs can be also used for a wrong purpose as well, to create, generate fake notes and, generate, for the deepfakes, basically. That's a major concern right now.
Deepfakes
So,
are also used for hatred purposes.
yes, 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 yes. So I hope like we reach we make an ecosystem that harbors the positive use of GANs. So
That actually gave rise to a new people like they will classify which are deepfakes and which are not.
yes, 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 I agree with you. So yes, that's definitely there. So
I forgot to mention a point.
yes, please.
In an image classification model or a say face recognition model, if I take a picture and add some permutations to it, I can even if I am Tarini Tanaya Mohapatra, I can be seen like Amlan Panigrahi. So it will make me see like Amlan Panigrahi. And if it is a security camera and if I am doing some crime, then you will be arrested.
Damn, man, I don't want to do. Already, there is a guy called Om in our community, in NUA, basically. He attempted
Yeah.
that. He attempted that, as in, like, he didn't rob a bank, and manipulate the CCTV footage with my face. He didn't go that extreme, but he manipulated the face, actually. He put my face on another person's image. And
Think
there
of the
was another
possibility when he
person.
actually can take
There
your
was,
face and do something.
yeah, you won't believe, like there was another person who, what he did was like on my face he inserted Modi's face. So uh, yeah,
That
Daichi
is
is
so
like,
crazy.
yeah, well done to the to whoever he did that. He uh,
So to just to counter that thing, adversarial attacks, we can use GANs there too.
yeah, 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 definitely. If for counter attack, yes. Um, so apart from that, anything else, Tarini, or anyone has any queries from the whoever is watching related to GANs or anything related to AI or deep learning? Any questions, or if you have any message for Daichi, anything, like you can just type in the chat. We'll just wait for a minute and then we'll just wrap up the session. Daichi is like, come on, guys, ask, shoot questions. Oh, lol. So, Tarini, anything else you wanted to mention?
Uh, Live long and prosper. I don't know what to say.
Live long and prosper. Okay. Daichi also says the same to you. Live long and prosper. In fact, to everyone. I hope the camera bug wouldn't have happened. Otherwise, he would be on camera right now. He would be saying
Yeah,
hello to
it will be
everyone.
fun to
I
see
would
him.
have been. Yeah. So never mind. So we'll be releasing more videos in Arts and Alpha related to the Jetson platform. I'll definitely try to get Daichi on the camera there. Those will be recorded, so no bugs, nothing. So yes, it was really an amazing and fun session, a very good session, Tarini. So
Yeah, same here. Thanks.
shall we bid farewell and wrap up, or anyone has any questions? So okay, Daichi is becoming impatient now. Suhan says hello to Daichi. Hey, Daichi also said hello to you, man. Hi, Suhan. Uh, so
He's actually saying an essay. We are not actually trying to get him. He's trying. He has said an essay here.
Daichi is done with the stream, it seems. Daichi.
We can actually use some deep learning models to like translate his language to human language.
Man, that's a fun project, man. You really suggested a very good idea. What do you think, Saurabh? And that's a cool idea, talking Daichi. Hello world. You would imagine Daichi is speaking. Hello world. My name is Daichi Kun. I am AI.
Humans will lose the shit.
Yeah, man. Fun.
Yeah,
I'll
yeah,
do that. Let's do that some. So let's wrap up then, Tarini. Thanks for your time. Thanks for your valuable time. Thanks
yeah.
for
Thanks for having me.
yeah, sharing your words of wisdom with everyone. Yeah. Hope we connect again for another fun session like this someday.
Yeah, yeah.
Yeah.
Looking forward for that.
So okay then. Okay.
Okay.
Uh, okay. Daichi's
Adios.
first sentence would be this: I is Daichi Kun. Y'all are my subjects. Now fetch me some treats. Of course. Of course. That will be his introductory statement. Yeah. He is the Nizam. He is the emperor of the world. We are his subjects. Okay then. Goodbye, guys. Goodbye from
Adios.
Daichi as well. Adios. Sayonara. Okay.
Live long and
Tada.
prosper.
Live long and prosper.
I
So
can't show my hand, but if my video cam was
yeah,
on, then that Star Trek would come on.
yeah. Host, you can end the session. We'll be connected here. Saurabh. Okay. We can talk here, na, for some time.